Lesson 1 Project Video Help. As you know, in mathematics, I is used to represent the imaginary numbers. However, in electricity and electronics, J is used to represent imaginary numbers because I in electronics represents currents. Scientists write any complex number in the form A plus JB. R equals R1 plus R2 plus R3. If the resistance of one component of a series circuit is 5 plus J4 ohms, and the resistance of the second component of the circuit is 3 minus J9 ohms, and the resistance of the third component of the circuit is 4 plus J7 ohms, what is the total resistance in the circuit? Alright, so we have our three resistances, so we're going to plug that into the formula for R1, R2, R3. So we're going to have R equals R1 is 5 plus J4 plus R2 is 3 minus J9 plus R3 is 4 plus J7. So in order to add this together, I just need to combine my like terms. So I have a 5, a 3, and a 4 are my three constants. So 5 plus 3 plus 4 gives me a 12. Plus, I then have a positive J4, negative J9, and a positive J7. So if I take the numbers 4 minus 9 gives me a negative 5, plus 7 gives me a positive 2. So I'm going to have a positive 2J. So then that would be my resistance, is 12 plus J2 is my total resistance in this circuit. I equals I1 plus I2. The total current of a parallel circuit is 15 plus J3 amps, and the current of one component of the circuit is 5 minus J2 amps. So what is the current of the other component of the circuit? So I'm going to take my equation here, and I'm going to plug in what I know. So I know that my total current, so my I here on the far left, is 15 plus J3, and that's going to equal my first current, which is 5 minus J2, plus I'm trying to figure out what the current of the second component is, so I'm going to leave my I2. So I need to solve for my I2. So the first thing I'm going to do is I need to get everything, I need to get all of this over to the other side. So I'm going to first start by subtracting the 5 from both sides. So 15 minus 5 gives me a 10 plus J3 equals a negative J2 plus I2. So now I need to get this negative J2 to the other side, so I'm going to add J2 to both sides. So then I have my 10 plus J3 plus J2, 3 plus 2 gives me a 5, so I have J5 equals I2. So the current in my other component is 10 plus J5 equals I2. V equals IR. What is the voltage in a circuit if the current is 7 plus J4 amps and the resistance is 4 minus J3 ohms? So I know that my voltage, so I'm looking for my voltage, so my formula is V equals IR. So I need to plug in what I know. So remember that I is the current. My current is 7 plus J4, so I'm going to have 7 plus J4 times my resistance, which is 4 minus J3. So now in order to solve this, I need to FOIL. So to FOIL, you can do the normal FOIL method of first, outer, inner, last, or some of you may have known the Punnett square method, where you set it up so you have 7 and J4, and then you have the 4 and the negative J3, and then you multiply, so 7 times 4 gives you a 28, 4 times J4 gives you a J times 16, negative J3 times 7 gives you a negative J21, and then negative J3 times J4 gives you a negative J squared 12. So you can do the Punnett square like that, and then you just add all of these in the center and do like terms, or you can do FOIL. So FOIL, remember, F stands for first, so I'm going to take 7 times 4, because those are my first terms. It gives me a 28. Outer, 7 and negative j3, because those are my outer terms. Gives me a minus j21. Inner is the j4 and 4. Gives me a positive j16. And then my last terms, j4 and negative j3, gives me a negative j squared times 12. So now I can combine like terms, so I have a negative j21 and a positive j16. So I get 28. Negative 21 plus 16 gives me a negative j5 minus a j squared 12. Now if you remember, j is the same as I, except for that in electronics they use j instead of I, since I stands for current. So if you remember, I squared equals negative 1. So j squared also equals that same thing. So for j squared, I can substitute in that j squared equals negative 1. So I'm going to plug that in where I have my j squared. So I now have 28 minus j5 minus a negative 1 times 12. So then I have a 28 minus j5. Negative 1 times 12 gives me a negative 12, and since I have a negative in front, a negative gives me a positive 12. Combine like terms. So positive 12 and 28, when I add those together, I get a 40 minus j5. So that is my voltage, is 40 minus j5. If you use the Punnett square, you can see that we have all the same values in our Punnett square that we had when we FOILed, and you would end up adding them and then doing these last same couple of steps in order to solve for it, just like you would in the other one. Okay? V equals IR. Refer to Ohm's law given in the previous question. If the voltage in a circuit is 40 plus J16 volts and the resistance is 5 plus J6 ohms, what is the current? So remember, we have V equals IR. So we know that the voltage is 40 plus J16. So I'm going to have 40 plus J16 is my voltage. My resistance is 5 plus J6. So I have my I times 5 plus J6. What is the current? So I want to solve for I. So I want to get rid of what I is multiplied by. So I'm going to divide by 5 plus J6 on both sides. So now I have 40 plus J16 divided by 5 plus J6 equals I. So now in order to solve this, I need to multiply the top and the bottom by the conjugate of my denominator. So my conjugate is, I'm just going to change the sign there. So I'm going to have 5 minus J6 is what I'm going to multiply the top and the bottom by, because that is my conjugate. So now I need to multiply that out in FOIL. So if I do 5 times 40, that gives me a 200. And then if I do my outers, 5 times J16 gives me a positive J80 minus J6 times 40. 6 times 40 gives me a 240. Minus J6 times plus a J16 gives me a minus J squared 96 divided by, now I'm going to do the bottom. 5 times 5 gives me a 25. 5 times j6 gives me a plus j30. Negative j6 times 5 gives me a negative j30. Negative j6 plus j6 gives me a negative j squared 36. So now I can go ahead and combine like terms. So on the top, I'm going to have 200 minus 80j minus a 240j gives me a minus j160. And then remember again that j squared equals negative 1, so I'm going to go ahead and substitute that in. Then combine like terms in the denominator, so I have a 25. j30 minus j30 cancels each other out. Then I still have my minus j squared, remember, is negative 1 times 36. So now I have a 200 minus j160 plus 96 when I multiply that out over a 25 plus 36. Combine like terms, I get a 296 minus j160 divided by 61, and that would be what my current is. 296 minus a j160 divided by 61. Hopefully this helps with your lesson 1 project.